Just like before, we need two methods here. A public method that we call from the outside and a private method that does all the recursive work. So public void traverse depth first. We give it the root as a string. And then our private method, private void with the same name, traverse depth first. Here we're going to pass a node object because this method is private and is part of the implementation detail. We also need a set for keeping track of the visited nodes. So set of node. And we call this visited. All right. Now, in our public method, we're going to call our private method. Here we use our nodes hash table to get this particular node and pass a new hash set object as a second argument. So this set that you see here is an interface and hash set is an implementation of this interface. Okay. Now, in this private method, first we should visit the root node. So we do a print line and print this root node. Now we should mark this as visited. So we use our set visited.add and pass the root object. Now we should recursively visit all the neighbors of this root node. So here we need a for each loop. For each node, now here we need to go to our adjacency list and find all the neighbors of this root node. So adjacency list that get root, this will return a list object. So for every node in this list, if we haven't visited this node, so if the visited set doesn't contain this node, then we're going to recursively call this method, pass this node object, and the same set of visited nodes. That's all you had to do. Pretty easy, right? It's very similar to how we implemented depth-first traversal in trees. Now let's test this. Back to the main class. This graph that you see here is exactly the one that you saw in the previous video. So now let's call graph.traverse depth first and start from the A. Let's see what we get. So we get A, B, D, and C. Now, what if you start from the C? We only see the C because the C is not connected to any other nodes. Here we have a directed graph. Every edge has a direction, right? Now, what if we start from a non-existent node? Let's say G. We get a null pointer exception. So let's quickly fix that. This exception happens when we try to find the neighboring nodes. Now, the proper way to prevent this exception from happening is to check for the existence of that node in our public method. So if this root that is passed here is not a valid node, we shouldn't kick off the recursion, right? So let's declare a variable called node. And here we call nodes.get with this root. If node is null, we're just going to return immediately. Again, I don't think we need to yell here. We don't need to throw an exception. Now, otherwise, we're going to pass this root node over here. Let's run the program one more time. The problem is fixed. So this is the recursive way of implementing the depth-first traversal. But we can also use iteration. And that's what we're going to look at next.